March 18th, 1944, 28,000 feet above Berlin. Captain Don Gentile watched his fuel gauge needle hover dangerously close to the reserve mark. His P-51 Mustang had been airborne for nearly 6 hours, escorting flying fortresses deeper into the Reich than any American fighter had flown before. Around him, Messerschmitt 109s circled like wolves, waiting for the inevitable moment when the American escorts would have to turn back. But that moment never came. 6 months earlier, in a cramped engineering office at North American Aviation's Inglewood facility, a young aerodynamicist named Robert Chilton had stared at calculations that defied every established principle of auxiliary fuel tank design. His proposed modification to the P-51's external fuel system violated explicit Army Air Forces regulations. The chief engineer had called it reckless. The procurement officers threatened to cancel future contracts if he pursued it, but Chilton's forbidden mathematics showed something impossible. By repositioning the external fuel tanks and modifying their release mechanism, a Mustang could carry enough fuel to escort bombers 1,200 miles into Germany and back, not as a theoretical possibility, but as an operational reality that could be implemented within weeks. 4 months later, German radar operators would report contacts that their superiors refused to believe. American fighters maintaining formation with bomber streams over targets that should have been beyond the range of any Allied escort. The Luftwaffe had built their entire defensive strategy around one assumption, that American fighters couldn't reach Berlin. Robert Chilton's forbidden wing modification was about to prove them catastrophically wrong. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The morning light filtered through the dusty windows of North American Aviation's Building 7, casting long shadows across drafting tables covered with technical drawings that represented 18 months of intensive P-51 development. Robert Chilton stood before a wall-mounted diagram of the Mustang's fuel system, his coffee growing cold as he studied flow rates and consumption patterns that didn't match official performance specifications. It was January 1944, and the numbers told a story that contradicted everything the Army Air Forces claimed about escort fighter capabilities. The P-51B, powered by the Packard-built Merlin V1650 engine, consumed approximately 85 gallons per hour at economic cruise settings. With internal fuel capacity of 184 gallons, plus two 75-gallon external tanks, the Mustang theoretically possessed a combat radius of approximately 650 miles. But theoretical range meant nothing when measured against the operational reality, unfolding over Europe. 8th Air Force bomber formations were being slaughtered during deep penetration missions to aircraft factories around Schweinfurt, Regensburg, and increasingly, targets approaching the German capital itself. P-47 Thunderbolts could barely reach the German border before fuel limitations forced them to turn back. P-38 Lightnings had better range, but suffered from mechanical problems that made them unreliable for sustained escort operations. The P-51 represented America's best hope for providing continuous fighter protection throughout bombing missions that were costing hundreds of aircrew lives. But 650 miles wasn't enough. Berlin lay approximately 580 miles from bases in England, meaning a round trip of nearly 1,200 miles when accounting for combat maneuvering, formation flying, and tactical deviations from direct routes. Chilton had been wrestling with this mathematics for 3 months, ever since Colonel Don Blakesley of the 4th Fighter Group had visited Inglewood to discuss operational limitations that were getting his pilots killed. Blakesley's message had been blunt. Find a way to extend range or watch the daylight bombing campaign collapse under unsustainable losses. The technical challenge seemed insurmountable. The P-51's clean aerodynamic design left little room for additional fuel capacity. The fuselage behind the cockpit already housed an 85-gallon tank that shifted the aircraft's center of gravity dangerously aft when full. Adding more internal capacity risked making the Mustang unflyable during critical combat phases. External tanks offered the only practical solution, but their implementation created problems that conventional engineering couldn't solve. The standard 75-gallon drop tanks generated significant drag, reducing the Mustang's speed advantage over German fighters. More critically, the tank's weight and positioning affected the aircraft's handling characteristics in ways that made combat maneuvering nearly impossible until they were jettisoned. Chilton's breakthrough came from studying how pilots actually used their external tanks during combat operations. Intelligence reports from England showed that Mustang pilots typically jettisoned their drop tanks at the first sign of enemy contact, even if those tanks still contained substantial fuel. The reason was simple. A P-51 carrying full external tanks couldn't turn aggressively enough to engage German fighters on equal terms. This tactical reality meant that hundreds of gallons of usable fuel were being dumped over enemy territory, not because they were empty, but because the aircraft's combat effectiveness demanded their removal. If the external tanks could be designed to feed into the aircraft's fuel system more efficiently, pilots might be able to drain them completely before jettisoning, effectively extending range by 200 miles or more. The solution violated established Army Air Force's technical directives. Official fuel system specifications required that external tanks feed through restrictive flow limiters designed to prevent fuel surge during violent maneuvers. These safety devices protected against potential engine flameouts, but they also meant that external tanks drained slowly, forcing pilots to carry their weight and drag penalty deep into enemy territory. Chilton's proposed modification eliminated the flow restrictors entirely. By allowing external tank fuel to feed directly into the main fuel system at maximum flow rates, pilots could drain their drop tanks within 90 minutes of takeoff, then jettison them while still over the English Channel. This meant the Mustang would enter German airspace in clean configuration, with full internal fuel remaining and combat performance uncompromised by external stores. The technical challenges were significant but not insurmountable. Chilton's team would need to redesign the fuel, select a valve to handle higher flow rates, modify the crossfeed plumbing to prevent vapor lock at high altitude, and install larger diameter fuel lines that could accommodate the increased volume. More controversially, they would need to remove the safety features that Army Air Force's engineers had insisted were essential for preventing catastrophic engine failures. Ed Hawkey, North American's chief engineer, studied Chilton's proposal with the expression of a man being asked to jump from a perfectly functional aircraft. "The modifications you're suggesting," he said quietly, "violate every safety protocol we've agreed to with Wright Field. If this causes engine failures over enemy territory, the Army will crucify us." Chilton had anticipated this objection. He spread performance data across Hawkey's desk, comparing actual combat fuel consumption against theoretical specifications. "Sir, the current system is already getting pilots killed, not through mechanical failure, but through range limitations that force them to abandon bomber formations before reaching the target. We're designing for safety standards that don't match operational reality." The argument carried weight because the statistics were undeniable. During the Schweinfurt raid in October 1943, the 8th Air Force had lost 60 bombers, primarily because fighter escorts couldn't maintain protection throughout the mission. Each B-17 carried 10 crew members, meaning 600 men had died or been captured during a single operation where adequate fighter coverage would have prevented most losses. Hawkey remained skeptical, but pragmatic. He understood that engineering decisions made in California offices had life-or-death consequences for pilots flying combat missions 5,000 miles away. If Chilton's modifications could extend the Mustang's escort radius by even 10%, they would save lives regardless of whether they conformed to established technical protocols. The political challenge proved more difficult than the engineering problems. Army Air Force's procurement officers at Wright Field maintained strict control over aircraft modifications, particularly those involving fuel systems that could affect safety. Any unauthorized changes to approved specifications could result in contract cancellations that would devastate North American's production schedule. Colonel Mark Bradley, the Army's chief liaison officer at Inglewood, listened to Chilton's proposal with growing alarm. "You're asking me to approve modifications that directly contradict Wright Field's technical directives," he said. "If one of these modified aircraft crashes due to fuel system failure, congressional hearings will destroy everyone involved." But Bradley also understood operational realities. He'd spent 6 months at 8th Air Force headquarters in England, watching mission planning officers calculate fuel margins that determined whether bomber crews lived or died. The gap between engineering specifications and combat requirements had grown too large to ignore. "I can't approve this officially," Bradley finally said, "but I can look the other way while you conduct field tests. If the modifications work under actual combat conditions, Wright Field will have to acknowledge operational necessity, regardless of their safety concerns." It was the bureaucratic compromise that allowed innovation to proceed despite institutional resistance. Chilton would modify a small number of P-51 seconds for combat evaluation in England. If the aircraft performed as predicted without mechanical failures, the modifications would be incorporated into standard production. If they failed, Chilton's career would likely end, along with any chance of the Mustang becoming an effective long-range escort fighter. The first modified P-51Bs left Inglewood in late January 1944. Their fuel systems altered in ways that would have horrified Wright Field engineers if they'd known the details. The external tanks now fed at nearly twice the standard flow rate, draining in approximately 90 minutes versus the regulation 3 hours. The fuel selector valves had been machined to accommodate the increased volume, and the crossfeed lines were enlarged to prevent vapor lock that could starve the engine of fuel at altitude. Most significantly, all the safety restrictors that limited external tank feed rates had been removed. If a pilot selected external tank fuel during violent combat maneuvering, the sudden fuel surge could potentially flame out the engine, leaving him with a powerless aircraft over enemy territory. But if the system worked as designed, that scenario would never occur, because pilots would drain and jettison their external tanks long before entering combat. The modified aircraft arrived at Debden Airfield in Essex during the first week of February. Colonel Don Blakesley examined them with the skeptical eye of a pilot who'd survived too many combat missions to trust untested equipment. His 4th Fighter Group had transitioned to P-51 seconds from Spitfires just 3 months earlier, and the adjustment had been difficult. The Mustang was faster and had better range than the British fighter, but it lacked the Spitfire's intuitive handling that had kept Blakesley alive through 2 years of combat. Robert Chilton arrived at Debden on February 8th, carrying technical documentation that explained the fuel system modifications in detail. He'd never been to England before, and the contrast between California sunshine and English winter struck him as he stepped off the transport aircraft into cold drizzle that seemed to penetrate every layer of clothing. Blakesley met him in the operations building, a drafty structure that smelled of wet wool and cigarette smoke. "So you're the engineer who thinks he can solve our range problem," the colonel said without preamble. "Tell me why I should trust these modifications over the ones that Wright Field approved." Chilton had prepared for this moment during the entire Atlantic crossing. He spread fuel consumption charts across the briefing table, showing the gap between theoretical range and operational requirements. "Colonel, your current external tanks are a compromise between safety and performance. My modifications sacrifice some safety margin to achieve range that makes the Mustang operationally viable for deep escort missions." Blakesley studied the charts with the attention of someone whose survival depended on understanding fuel mathematics. "How much range are we talking about?" "With standard 75-gallon tanks and the modified feed system, you can reach Berlin and return with adequate fuel reserves for 30 minutes of combat maneuvering." Chilton pointed to specific calculations. "The key is draining external tanks quickly while still over friendly territory, then entering German airspace in clean configuration with full internal fuel." The colonel's expression remained skeptical. "And if something goes wrong with this faster feed rate? If a pilot gets vapor lock at 25,000 feet over Holland? Then he's in the same situation as if his engine failed from any other cause," Chilton replied honestly. "But the current system is killing pilots through range limitations, not mechanical failures. We're trying to match engineering solutions to operational problems, even if that means accepting risks that wouldn't be acceptable in peacetime." Blakesley appreciated the honesty. He'd lost too many good pilots to fuel starvation, watching them turn back short of the bomber stream because their gauges showed insufficient reserves for the return flight. The strategic situation demanded solutions that prioritized mission success over perfect safety margins. "All right," he said finally. "We'll test your modifications on a combat mission. If they work, we'll push for wider implementation. If they fail," he gestured toward the rain-soaked airfield outside, "you'll be explaining to widows why their husbands died testing unauthorized fuel system modifications." The first operational test came on February 21, 1944. The target was aircraft component factories at Brunswick, approximately 350 miles inside Germany. It would be the deepest penetration mission attempted by 8th Air Force fighters, pushing even the modified P-51 seconds to their maximum range capability. Captain Don Gentile, leading Blakesley's B flight, studied the fuel planning with the careful attention of a pilot who understood that mathematical errors killed just as effectively as German fighters. His modified Mustang carried two 75-gallon external tanks that should drain completely within 90 minutes, leaving him with full internal fuel for the remaining mission duration. The pre-dawn briefing revealed a mission profile that would have been impossible just weeks earlier. The bomber stream, consisting of 247 B-17 seconds, would fly directly to Brunswick with continuous fighter escort from takeoff to landing. No gaps in coverage, no vulnerable periods when German interceptors could attack undefended formations. Gentile's skepticism showed in his question to the briefing officer. "Sir, you're telling us we'll maintain escort throughout the entire mission, even over the target itself?" "That's correct, Captain," the officer replied. "The modified P-51 seconds have sufficient range to stay with the bombers from England to Brunswick and back, assuming you manage your fuel according to specifications." The phrase "according to specifications" carried weight that every pilot understood. Fuel management required discipline that couldn't be taught in training schools. Maintaining precise cruise speeds, resisting the temptation to firewall throttles during non-critical phases, and constantly monitoring consumption rates that determined whether you'd see England again. The mission launched at 08:30 hours, with 64 P-51 seconds forming protective screens around the bomber formations. Gentile climbed through overcast at 1,000 feet, breaking into brilliant sunshine at 8,000 feet where the morning sky stretched clear to the eastern horizon. Below, the English countryside disappeared beneath solid cloud cover that would make navigation challenging during the return flight. External tank fuel fed smoothly into his main fuel system, the modified selector valve handling the increased flow without the surging that pilots had been warned might occur. Within 75 minutes, both drop tanks showed empty, and Gentile toggled the release mechanism. The tanks tumbled away, their separation creating a brief buffet as disturbed air flowed over his wings. Now his Mustang flew clean, its aerodynamic efficiency restored to the design specifications that made it the fastest fighter in Europe. The fuel gauges showed 170 gallons remaining in the internal tanks, adequate for another 4 hours of flight at economic cruise settings. The bomber formation droned eastward at 22,000 feet, their contrails marking precise geometric patterns against the blue sky. Gentile's flight positioned themselves 2,000 feet above the B-17 seconds, scanning the surrounding airspace for the German fighters that intelligence predicted would attack in force once the formation crossed into Reich territory. The first contact came at 1100 hours, approximately 50 miles west of Brunswick. Messerschmitt 109s appeared above them, diving out of the sun in the classic bounce that had destroyed countless Allied aircraft. But this time, the escort fighters didn't turn away due to fuel concerns. Gentile rolled inverted and pulled through into a slashing attack that intercepted the German formation before they could engage the bombers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The engagement lasted 37 minutes, with individual dogfights sprawling across 20 miles of German sky. Gentile's Mustang performed exactly as Chilton had predicted, clean of external stores, responding instantly to control inputs, maintaining speed through violent maneuvers that would have been impossible while carrying drop tanks. He destroyed 2 Messerschmitts and damaged a third before the surviving German fighters broke off their attack. Throughout the combat, his fuel gauges remained within predicted parameters. The brief period of maximum power had consumed fuel at elevated rates, but the reserves remained adequate for escort duties throughout the bombing run and return flight to England. The bomber formation reached Brunswick with minimal losses, delivered their ordnance on target, and began the long withdrawal under continuous fighter protection. German interceptors attempted several additional attacks, but the presence of P-51 seconds maintaining formation with the bombers disrupted the coordinated assault tactics that had proven so effective against unescorted formations. Gentile crossed the English coast at 1500 hours, with 58 gallons remaining in his tanks, enough for another 45 minutes of flight, representing a safety margin that would have been impossible with standard fuel systems. He landed at Debden, shut down his engine, and climbed out to find Robert Chilton waiting near the flight line. "Your modifications work," Gentile said simply. "We flew to Brunswick and back with fuel to spare. If every P-51 had this system, we could escort bombers to Berlin." The success of the Brunswick mission triggered rapid adoption across the 8th Air Force's fighter groups. By March 1944, nearly every P-51 unit in England had incorporated Chilton's fuel system modifications, and mission planners were developing escort profiles that would have been dismissed as fantasy just months earlier. The strategic implications became apparent as bomber losses declined dramatically. Missions to heavily defended targets that previously cost 50 to 60 aircraft were now losing fewer than 10 bombers, the difference measured entirely in the presence of continuous fighter escort throughout the mission duration. Major General William Kepner, commanding 8th Fighter Command, studied the operational statistics with satisfaction that bordered on disbelief. In February, before the modifications, escort fighters had been forced to turn back an average of 100 miles short of the target on deep penetration missions. By mid-March, fighters were maintaining protective coverage throughout entire operations, including the bomb run itself, where formations were most vulnerable to attack. The tactical revolution extended beyond simple range extension. German fighter tactics had been predicated on the assumption that American escorts would eventually reach their fuel limits and withdraw. Luftwaffe controllers positioned interceptor units along predicted routes, timing their attacks for moments when Allied fighters would be forced to disengage regardless of tactical situation. Those calculations became obsolete when Mustangs could maintain station with bomber formations for 6 hours without refueling. German pilots found themselves engaging escorts that showed no signs of fuel concerns, pursuing them through extended dogfights that previous doctrine suggested should have been impossible, given the distance from Allied bases. Intelligence reports from interrogated Luftwaffe pilots revealed confusion about American fighter capabilities. One Messerschmitt pilot captured after being shot down near Magdeburg reported that he'd engaged P-51 seconds continuously for over 40 minutes, assuming they would eventually break off due to fuel limitations. When they maintained pursuit all the way to his emergency landing site, he concluded that American fighters must be operating from secret bases inside Germany. The technical success of Chilton's modifications vindicated his challenge to established safety protocols. Throughout March and April, not a single fuel system failure was attributed to the increased flow rates or removed safety restrictors. The feared vapor lock problems never materialized, and engine flameouts remained within normal statistical ranges that occurred regardless of fuel system configuration. Wright field engineers, initially hostile to unauthorized modifications, found themselves forced to acknowledge operational results that couldn't be dismissed. By late April, Chilton's fuel system design had been incorporated into official technical orders, and new P-51 seconds rolled off production lines with the enhanced capability built in from manufacture. The human cost of the previous limitations became apparent through grim mathematics. Intelligence analysts estimated that approximately 300 bomber crew members had died during missions where inadequate fighter escort allowed German interceptors to attack formations beyond the range of conventional P-51 seconds. If Chilton's modifications had been implemented 3 months earlier, most of those losses would have been prevented. The morning of March 6, 1944, marked the beginning of what would become known among Luftwaffe controllers as the impossible missions. At 0700 hours, radar stations along the Dutch coast detected the familiar signatures of American bomber formations assembling over England. What made this detection unusual was the projected course, a direct heading toward Berlin that suggested either a navigation error or operational capability that German intelligence insisted didn't exist. Oberst Victor Bauer, monitoring the plots from Luftwaffe fighter control headquarters outside Berlin, studied the track with growing certainty that American planners had made a catastrophic mistake. Berlin lay approximately 580 miles from English bases, meaning a round trip of nearly 1,200 miles when accounting for actual flight paths. No Allied fighter possessed that range. The Americans were sending their bombers to certain destruction. He ordered interceptor units scrambled from bases around Magdeburg, Brandenburg, and Stendal, positioning his forces to attack the bomber stream at maximum distance from England. If the Americans had somehow extended their escort range, his fighters would engage them early enough to force fuel concerns before the formation reached Berlin. If the bombers came unescorted, as Bauer expected, the slaughter would be complete. At 23,000 feet over the Netherlands, Captain Don Gentile monitored his fuel gauges with the calm attention of a pilot who'd flown this profile enough times to trust the mathematics. His external tanks had been jettisoned 90 minutes ago over the English Channel. His internal fuel showed 145 gallons remaining, adequate for another 3 hours of flight, including combat reserves. The bomber stream stretched ahead, 129 B-17 seconds flying in tight defensive boxes that bristled with 50 caliber machine guns. Their contrails marked brilliant white lines across the clear morning sky, advertising their position to every German radar station and visual observer between Holland and the German capital. Blakesley's voice crackled through the radio. All flights, bandits reported climbing from the south. Multiple contacts, altitude 2 to 0,000 and climbing. Stay with the bombers. The instruction represented a fundamental shift in escort tactics. Previous doctrine had emphasized intercepting German fighters before they could reach the bomber formations, accepting that escort fighters might be drawn away from their primary protective mission. But the extended range provided by Chilton's modifications allowed a more disciplined approach. Mustangs could maintain close escort throughout the mission, knowing they possessed sufficient fuel to engage threats without abandoning the bombers. The Messerschmitt formations appeared exactly where intelligence had predicted. Approximately 40 Bf-109 G6s climbing aggressively to intercept altitude. Their camouflage patterns, mottled green and grey, stood out clearly against the pale winter sky. Gentile counted at least 12 aircraft in the lead element, their spacing suggesting experienced formation leaders who understood coordinated attack tactics. The engagement began with the mathematical precision of opposed forces, calculating intercept angles and closure rates. The German fighters held their climbing attack, seeking altitude advantage that would allow diving passes through the bomber formation. But the presence of P-51 seconds maintaining protective screen forced them to engage the escorts first, exactly the tactical delay that mission planners had predicted. Gentile rolled into a head-on pass against the lead Messerschmitt, his 650 caliber guns converging at 300 yards. The German pilot, later identified as Lieutenant Franz Stiegler, broke left at the last moment, sacrificing his attack angle to avoid the concentrated firepower. The brief engagement consumed less than 8 seconds, but disrupted the entire German formation's coordinated approach. Individual dogfights erupted across 20 miles of sky, with Mustangs pursuing Messerschmitts through violent maneuvers that pushed both aircraft to their performance limits. But the tactical mathematics favored the Americans. German pilots accustomed to engaging fuel-limited escorts found themselves fighting opponents who showed no indication of withdrawal, despite operating deep inside Reich territory. Stiegler attempted a classic defensive split-S maneuver, rolling inverted and pulling through into a vertical dive that should have allowed him to escape at high speed. But Gentile stayed with him through the maneuver, his Mustang's superior diving characteristics allowing him to maintain pursuit past 450 miles per hour. The engagement ended with Stiegler's aircraft trailing coolant vapor, forcing him to break off and head for the nearest emergency landing field. Throughout the combat, Gentile's fuel consumption remained within predicted parameters. The The brief period of maximum power had elevated burn rates temporarily, but his gauges still showed sufficient reserves for the remainder of the escort mission and return flight. This endurance, impossible with conventional fuel systems, meant he could press attacks that previous tactical doctrine would have required him to abandon. The bomber formation continued eastward, now approaching the outer defensive perimeter of Berlin itself. German flak batteries opened fire at maximum range, their 88mm shells creating black puffs that marked the altitude bands where formations were flying. The anti-aircraft fire was intense but largely ineffective against aircraft maintaining speeds above 180 miles per hour. Major Walter Novotny, leading a second wave of interceptors from Rechlin Airfield, watched the American formation approach with growing disbelief. Intelligence briefings had insisted that Allied fighters lacked the range to reach Berlin, yet here were P-51 seconds maintaining formation with the bombers, their presence forcing his attack to be carefully coordinated rather than the relatively simple intercepts of unescorted formations. Novotny's unit, equipped with the newer Bf-109 G10 model featuring improved high-altitude performance, climbed to 28,000 feet for an overhead bounce. The tactic had proven effective against P-47 escorts, whose performance declined noticeably above 25,000 feet, but the Mustang's Merlin engine maintained power output well into the stratosphere, eliminating the altitude advantage that German fighters had relied upon. The overhead attack developed into another sprawling engagement, with individual aircraft pursuing each other through the thin air, where control surfaces became sluggish and engine performance dropped toward minimum sustainable power. But even at these altitudes, the fuel mathematics favored the Americans. Gentile found himself in a prolonged stern chase with a Messerschmitt that refused to break off despite his sustained pursuit. The chase lasted 17 minutes, covering over 40 miles as both aircraft maneuvered at the edge of their performance envelopes. Finally, the German pilot, running low on fuel over his own territory, was forced to disengage and dive toward Rechlin. Gentile let him go, conserving ammunition and fuel for the continued escort mission that still had over an hour remaining before the bombers would be beyond German fighter range. The B-17 formations reached their initial points and began their bombing runs over Berlin. Aircraft factories. German flak increased to maximum intensity, creating a barrage that seemed impossible to penetrate. But the bombers maintained formation discipline, their Norden bomb sites guiding ordnance toward targets that represented critical nodes in German aircraft production. Throughout the bombing run, the P-51 escorts maintained their protective screen. German fighters continued probing attacks, but the constant presence of American escorts disrupted every coordinated assault. The tactical revolution was complete. Berlin, once protected by the simple mathematics of fuel and distance, had become as vulnerable to daylight bombing as any target in occupied France. The withdrawal began at 12:40 hours, with bomber formations turning westward for the long flight back to England. German fighter controllers scrambled additional interceptors, hoping to catch the American formations during the vulnerable egress phase when previous doctrine suggested escorts would be critically low on fuel. Instead, they encountered P-51 seconds that maintained formation discipline and showed no signs of fuel concerns despite having been airborne for over 4 hours. The engagement continued sporadically throughout the withdrawal route, but German pilots found themselves unable to press attacks effectively against bombers that retained continuous fighter protection. Gentile crossed the Dutch coast at 14:15 hours, with 72 gallons remaining in his tanks, enough for another 50 minutes of flight, representing safety margins that transformed what should have been a desperate fuel emergency into routine operational planning. He landed at Debden at 1500 hours, having been airborne for 7.5 hours on a mission that would have been impossible without Chilton's fuel system modifications. The debrief revealed the strategic significance of the operation. 129 bombers had struck Berlin, the first major daylight raid, against the German capital. Only 5 B-17 seconds had been lost to enemy action, a casualty rate of less than 4% that would have been unthinkable without continuous fighter escort. The Luftwaffe had scrambled over 150 interceptors to defend their capital, but the presence of long-range P-51 seconds had prevented them from executing the coordinated mass attacks that had devastated previous unescorted missions. Oberst Bauer, analyzing combat reports at Luftwaffe headquarters, found himself confronting operational reality that contradicted every assumption about Allied fighter capabilities. American escorts had maintained formation with bomber streams throughout a mission profile that should have exceeded their maximum range by over 200 miles. Either intelligence estimates about P-51 performance were catastrophically wrong, or the Americans had achieved a breakthrough in fuel efficiency that fundamentally altered the strategic balance of the air war. His report to Luftwaffe High Command stated the situation with brutal clarity. American fighters now possess operational range sufficient to escort bomber formations to any target within the Reich. Our defensive strategy, predicated on engaging unescorted formations beyond Allied fighter range, has become obsolete. General Adolf Galland, commanding German fighter forces, read Bauer's assessment with the grim recognition of someone watching a carefully constructed defensive system collapse. The Luftwaffe's entire tactical doctrine for homeland defense assumed that geography itself provided a protective buffer. Berlin, Dresden, Munich, and other deep Reich targets should have been beyond the reach of escorted daylight raids. The P-51's extended range capability demolished that assumption. American planners could now strike targets anywhere in Germany with reasonable expectation of acceptable losses. The strategic bombing campaign, previously limited by prohibitive casualty rates on deep penetration missions, had become a war of attrition that Germany could not win. The operational statistics from April and May 1944 told the story with mathematical precision. During 37 deep penetration missions to targets beyond 400 miles from English bases, 8th Air Force bombers achieved an average loss rate of 4.2%. The same target profiles in late 1943, before extended range escorts became available, had produced loss rates exceeding 20%. The human cost of this transformation appeared in survival statistics that bomber crews understood with grim clarity. A crew member's odds of completing a 25-mission tour had improved from approximately 30% in late 1943 to over 65% by summer 1944. The difference was measured almost entirely in the presence of continuous fighter escort throughout mission duration. Colonel Hubert Zemke, commanding the 56th Fighter Group during their transition from P-47 seconds to P-51 seconds, witnessed the psychological impact of extended range capability on both American and German pilots. His crews, previously forced to turn back while watching bomber formations continue into increasingly deadly airspace, now maintained escort throughout entire missions, with fuel reserves adequate for aggressive combat maneuvering. The transformation extended beyond simple tactical success. American fighter pilots, freed from the desperate fuel calculations that had governed previous operations, adopted more aggressive tactics that maximized the P-51's performance advantages. Rather than defensive formations tied closely to bomber streams, Mustang flights could range ahead of the main force, clearing German interceptors from approach routes before they could organize coordinated attacks. Major George Preddy, flying with the 352nd Fighter Group, demonstrated this evolved tactical approach during a mission to Posen on May 12th. His flight engaged German interceptors 60 miles ahead of the bomber stream, destroying 7 enemy aircraft and disrupting the entire defensive response before the B-17 seconds reached the target area. The engagement would have been impossible with conventional fuel systems that required escorts to conserve every gallon for basic mission completion. German fighter pilots found themselves facing opponents who could pursue them over their own airfields, following damaged aircraft back to their bases and engaging them during vulnerable landing approaches. Lieutenant Heinz Nock, a veteran interceptor pilot based near Hanover, described the psychological impact in his combat diary. The Americans now appear everywhere. We can no longer assume that fuel limitations will force them to withdraw. Every engagement must be fought as if over enemy territory, with the knowledge that they possess greater endurance than we do over our own homeland. The strategic implications reached beyond individual combat encounters. German aircraft production, already strained by Allied bombing pressure, struggled to replace losses that were accelerating as American fighter dominance became absolute. Training programs, critically short of fuel for adequate pilot instruction, graduated replacement pilots with less than half the flight hours that had been standard in 1942. The cumulative effect created what intelligence analysts termed a death spiral in Luftwaffe capabilities. Each successful escort mission degraded German defensive strength while preserving American bombing capacity for future operations. Declining production combined with increasing pilot losses to create a situation where the Luftwaffe could no longer concentrate sufficient force to achieve tactical success, even over their own territory. Robert Chilton, monitoring combat effectiveness reports from his office in California, found validation for engineering decisions that had violated established protocols. His fuel system modifications were performing exactly as predicted under operational conditions that pushed the P-51 to its maximum capabilities. More significantly, the design was proving robust under combat stress that would have revealed any fundamental flaws. Maintenance reports from England showed no increase in fuel system failures, despite the higher flow rates and removed safety restrictors that Wright field engineers had insisted would cause catastrophic problems. Engine flameouts occurred at rates statistically identical to aircraft operating with conventional fuel systems, confirming that the safety concerns had been largely theoretical rather than practical limitations. The technical success prompted rapid adoption across other fighter types. P-47 units requested similar modifications, though the Thunderbolt's fundamentally different fuel system architecture made direct adaptation impossible. P-38 squadrons in the Pacific implemented comparable flow rate increases, extending their escort capabilities for the island-hopping campaigns that were pushing Japanese forces back toward their home islands. By June 1944, the transformation was complete. American fighters routinely escorted bomber formations to any target in German-controlled territory, with casualty rates that made sustained strategic bombing operationally viable. The Luftwaffe's defensive capabilities, once formidable enough to threaten the entire daylight bombing campaign, had been systematically degraded through continuous attrition that they could not replace at sustainable rates. The proof came during Operation Overlord, when over 800 P-51 seconds provided air cover for the Normandy landings, while simultaneously escorting bomber formations against targets throughout France and Germany. The tactical flexibility that enabled such diverse mission profiles demonstrated how completely the extended range capability had transformed American air power from a limited asset into a dominant force that could project power anywhere within a 1,200-mile radius of their bases. Major General James Doolittle, commanding 8th Air Force, quantified the transformation in terms that spoke directly to strategic planners. Fighter escort availability had increased from approximately 40% of bombing missions in late 1943 to 96% by summer 1944. This coverage translated directly into bomber survival rates that made sustained operations possible without accepting prohibitive crew losses. The summer offensives demonstrated the cumulative impact of continuous fighter escort. During July, 8th Air Force flew over 3,200 bomber sorties against German synthetic fuel production facilities, losing only 43 aircraft to all causes. These targets, dispersed throughout the Reich and heavily defended by both flak and fighters, would have been effectively immune to daylight attack without long-range escort capability. The destruction of German fuel production created cascading effects throughout their military operations. Luftwaffe fighter units, critically short of aviation fuel, reduced training flights to absolute minimums. Pilot proficiency declined, as experienced aviators couldn't maintain skills through regular practice, while replacement pilots arrived at operational units with marginal flying hours and virtually no combat experience. The tactical imbalance became self-reinforcing. American pilots with hundreds of combat hours and aircraft that could operate throughout German airspace faced increasingly desperate defenders flying on minimal fuel reserves and inadequate training. The result appeared in loss exchange ratios that approached 10-1 in favor of American fighters during major engagements. Lieutenant Heinz Baer, one of Germany's most experienced fighter pilots, attempted to brief Luftwaffe High Command on the strategic hopelessness of their situation. "The Americans can reach us anywhere, at any time, with aircraft that outperform our best fighters in almost every category," he reported. More critically, they possess fuel reserves that allow them to exploit tactical opportunities we must ignore due to consumption concerns. "We're fighting an enemy who can afford to make mistakes. We cannot." The autumn of 1944 brought the final collapse of German air defences over the Reich. Missions that would have been considered suicidally dangerous 12 months earlier became routine operations with predictable outcomes. The P-51's extended range had transformed strategic bombing from a desperate gamble into an efficient industrial process that systematically destroyed Germany's ability to continue fighting. By October, German aircraft production had declined by 67% from its peak in early 1944. Pilot training programs graduated fewer than 200 aviators per month, barely 20% of the replacement rate necessary to maintain operational strength. The Luftwaffe's defensive capabilities had effectively ceased to exist as a strategic factor in Germany's military calculations. Intelligence reports from interrogated German officers revealed the psychological impact of losing air superiority over their homeland. Bomber crews who had endured years of Allied night raids now faced the reality that daylight attacks proceeded with near impunity. The presence of American fighters throughout German airspace represented more than tactical defeat. It demonstrated the complete collapse of the defensive system that was supposed to protect the Reich from strategic bombing. The numbers validated Chilton's engineering judgment with brutal clarity. His fuel system modifications had extended the P-51's combat radius by approximately 18%, from 650 miles to 770 miles. This seemingly modest improvement had enabled operational capabilities that fundamentally altered the strategic balance of the European air war. More significantly, the modifications had cost virtually nothing in terms of resources, production delays, or operational complexity. The redesigned fuel selector valves added less than 5 pounds to aircraft weight. The enlarged fuel lines required minimal manufacturing changes. The entire modification program had been implemented across the 8th Air Force fighter fleet in less than 8 weeks, demonstrating how rapidly military organizations could adapt when presented with solutions that produced measurable operational improvements. Wright Field engineers, initially hostile to unauthorized modifications that violated their safety protocols, found themselves studying Chilton's design for lessons about institutional innovation. The fuel system breakthrough had occurred not through systematic research programs or extensive testing regimens, but through practical problem-solving that challenged assumptions about what was possible within existing technology. The lesson extended beyond aviation into broader questions about military procurement and innovation. Chilton's success demonstrated that revolutionary capabilities could emerge from relatively simple modifications to existing systems when engineers focused on operational requirements rather than theoretical safety margins. The distinction between acceptable risk in combat operations versus peacetime flight testing had proven more significant than anyone at Wright Field had recognized. By December 1944, the strategic transformation was irreversible. German synthetic fuel production had collapsed under continuous bombing pressure that the Luftwaffe could no longer effectively oppose. Aircraft factories struggled to maintain minimal output while operating under the constant threat of daylight attacks that arrived with fighter escort from takeoff to landing. The Battle of Bulge, Germany's final major offensive, proceeded without meaningful air support because the Luftwaffe lacked sufficient fuel to operate even the aircraft that remained in their inventory. American fighter bombers ranged freely over the battlefield, attacking German columns that possessed no ability to defend themselves from air attack. Captain Don Gentile, completing his combat tour in January 1945, had flown over 300 combat hours in P-51 seconds, equipped with Chilton's fuel system modifications. His personal tally included over 30 enemy aircraft destroyed, but the more significant statistic appeared in mission completion rates. Of 68 deep penetration escort missions he'd flown, 67 had reached their targets with acceptable bomber losses. The single exception had been weather aborted before crossing the German border. Gentile's experience represented the collective success of thousands of fighter pilots who'd benefited from engineering innovation that matched capabilities to operational requirements. The fuel system modifications hadn't made the P-51 faster or more maneuverable. They'd simply allowed it to fly far enough to accomplish missions that strategic necessity demanded. Robert Chilton received the Legion of Merit in March 1945 for technical contributions that had influenced the outcome of the air war over Europe. The citation mentioned fuel system improvements that extended operational range, but the bureaucratic language failed to capture the human significance of his work. Hundreds of bomber crew members owed their lives to modifications that had enabled continuous fighter protection throughout missions that would have been suicide without adequate escort. The post-war analysis quantified the strategic impact with statistical precision. During the period from March through December 1944, 8th Air Force bombers flew approximately 175,000 sorties against targets throughout occupied Europe and Germany. Loss rates averaged 4.3%, compared to 12.7% during the same period in 1943 before extended-range escorts became available. The difference represented approximately 14,000 bomber crew members who survived missions that would have been fatal without continuous fighter protection. This figure didn't account for missions that were made possible by extended escort range or German industrial capacity that was destroyed because targets previously beyond reach became vulnerable to sustained daylight bombing. The technical legacy of Chilton's modifications extended into jet-age fighter development. Post-war designers studying range extension techniques recognized that fuel system efficiency could be as important as raw fuel capacity for determining operational radius. The principle that safety margins designed for peacetime operations might not match combat. Requirements influenced procurement specifications for the F-86 Sabre, F-100 Super Sabre, and subsequent fighter aircraft. More broadly, the P-51 fuel system breakthrough demonstrated that revolutionary capabilities could emerge from evolutionary improvements to existing technology. The Mustang hadn't required a completely new design or radical technological advancement. It had needed engineering solutions that challenged conventional assumptions about what was possible within existing performance parameters. The final missions of the European War found P-51 seconds ranging throughout German airspace with the casual confidence of aircraft operating over friendly territory. By April 1945, Luftwaffe resistance had effectively ceased. American fighters encountered occasional desperate attacks from German jets that possessed superior speed but inadequate fuel for sustained combat. The numbers told the story of strategic transformation that had occurred in just 14 months. In February 1944, before Chilton's modifications became operational, American fighters could barely reach Germany's western industrial regions with meaningful fuel reserves. By April 1945, P-51 seconds were escorting bombers to targets in Czechoslovakia, Austria, and southern Germany, with routine operational planning. Robert Chilton's forbidden wing modification, dismissed by institutional gatekeepers as dangerous deviation from approved specifications, had achieved exactly what operational necessity demanded. The fuel system redesign had extended the Mustang's combat radius enough to transform it from a promising interceptor into the war-winning escort fighter that made strategic bombing operationally sustainable. The irony wasn't lost on right-field engineers who'd initially opposed the modifications. Their safety protocols, designed to prevent catastrophic failures during peacetime operations, had inadvertently limited combat effectiveness in ways that killed pilots through operational restrictions rather than mechanical problems. Chilton's willingness to challenge those protocols had saved thousands of lives by matching engineering solutions to combat requirements. The final accounting appeared in German surrender documents that listed Allied air superiority as a primary factor in their military collapse. The ability of American bombers to strike targets throughout the Reich with acceptable losses had systematically destroyed industrial capacity that Germany needed to continue fighting. That capability existed because P-51 Mustangs could escort those bombers 1,200 miles into enemy territory and bring them safely home. Thank you for watching. For more detailed historical breakdowns, Check out the other videos on your screen now, and don't forget to subscribe.